Okay, so today at practice we did this drill where basically you had to run from one goalpost to the other back and forth, and like you had to attack, and then if you missed you had to defend, and it was literally like basically running back and forth full field sprints. It was really tiring. But I want to relate this to our acid and base module that we've been talking about. So during high intensity exercise, like these full field sprints we're having to do, the body produces a high concentration of hydrogen ions or acid from ATP breakdown and fast glycolysis, which lowers pH because we're increasing the number of hydrogen ions in our body. And yeah, to prevent this drop in the pH, to prevent an increase in acidity, the body relies on the bicarbonate buffer system or the blood buffer system. Basically, how this works is when we have acid or hydrogen ions in the blood, it interacts or combines with bicarbonate to make carbonic acid. The carbonic acid is carried to the lung, or in the lungs, it'll dissociate into water and CO2. And when we exhale, we get rid of the CO2. When we have CO2 in the muscles, though, it'll leave the muscle and through the bloodstream. It gets carried to the lungs, and the CO2 will combine with water to make carbonic acid. It's like kind of the opposite, like the reversible of what I just said. To make carbonic acid, the carbonic acid will dissociate into bicarbonate and a hydrogen ion. That hydrogen ion will then interact with hemoglobin. It kicks off oxygen. Oxygen goes to the muscles to do bioenergetics. And at the same time in the plasma, we have the step one that I was just describing, how when the acid is in the bloodstream, interacts with bicarbonate, whatever. And that's all happening with high intense exercise to keep acid out of our muscles and acid out of our bloodstream.